After that, oscillator, transistor oscillator. Now we are going to see the transistor oscillator. So transistor oscillator, see the circuit, it has the tank circuit, amplifier and feedback network. The transistor oscillators are used to producing the oscillation for producing the different frequencies. So here the transistor oscillator has the three important parts, that is tank circuit, amplifier and the feedback circuit. So in the diagram, first one, that amplifier. Amplifier, you know that now only we finish that amplifier. So there is the amplifier, that signal was amplified by the amplifier. So transistor is used as amplifier. So we know that what is amplifier. Next thing is feedback network. The feedback network means the feedback network is used to increase or decrease the current gain of the amplifier. So it has the two, what is meant by feedback means one portion of the output of the amplifier. Again, it is fed back into the feedback network. See, this is an amplifier. It's amplified, the signal comes out through the P output. One part of the output of that amplifier, again it is fed back into the amplifier, is called feedback amplifier. Or this network is called feedback network. அப்ப ஆம்பிளிஃபையர்ல இருந்து ஒரு அவுட்புட்ல ஒரு பார்ட்டை மட்டும் திரும்ப என்ன பண்றோம் அப்படின்னா again நம்ம திரும்ப ஆம்பிளிஃபையருக்கே கொடுக்குறோம். So that is called feedback network. So that is used for improving the signal. So using that we can maintain the stability of the amplifier. Next one is see the tank circuit. So this is called tank circuit. In that tank circuit means, tank means you know that water filled in the tank means it will retain for a long time. Like that, when the energy is given to the tank circuit, it will retain in a long time. It's called a tank. See, the tank circuit is here, the picture, near the picture. This is called tank circuit. So C1, this is called capacitor, and this is resistance, and this is inductance. Okay. So the tank circuit animation is here. See that here this is an inductor and this is capacitor. So when the energy is discharged from the capacitor, that is stored in the inductor in the form of electromagnetic energy. Again, that electromagnetic energy is disturbed. Again, it is converted into energy stored in the capacitor. So the capacitor energy is produced in the magnetic field in inductance. That magnetic field again it is stored in the form of charges in the capacitor. So it continuously occurs alternatively. So once we give the energy, continuously it is producing the electromagnetic energy and capacitance like this. So this is called a tank circuit. So this is called a tank circuit. So the tank circuit is fixed here. So the tank circuit producing the oscillation. Then oscillation means it's producing the damped oscillation. That means the energy of the oscillation is decreases. But the amplifier is tanked out to the tank circuit. So what is the amount of energy decreases in the tank circuit? That energy is supplied from the amplifier. அப்ப tank circuitல இருந்து oscillate ஆகி ஒரு alternate energy produce பண்ணிட்டு இருக்கீங்க அப்படின்னா, that definitely it has some energy loss. So that energy loss means it produces the damped oscillation. What is the amount of energy is losses in the tank circuit? That energy is supplied from the amplifier. So it will oscillate against the full energy. So it is that oscillation is called undamped oscillation. So this is the process of producing the undamped oscillation by using the amplifier. So amplifier, we can produce the amplifier. Then frequency produced by the oscillator is F is equal to 1 by 2 pi root of LC. See here, this is the formula. So frequency F is equal to 1 by 2 by root of LC, where F is the frequency, L is the inductance value, C is the capacitance value. So substituting all the values, you can calculate the frequency which is produced from the oscillator. So to working condition for sustained oscillation. Sustained means undamped oscillation must be produced for a long time. What is the condition for producing the undamped oscillation? Means that the following two conditions are there. One is the loop phase must be 0 or integral multiples of 2 pi. That value must be 0 or 2 pi. The integral multiples of 2 pi. The second thing, the loop gain must be A beta. A is the current gain, beta also a current gain. So A beta is the current gain, that is equal to what? So A beta equal to 1, that loop must be. The loopங்கிறது நீங்க இப்பதான் பார்த்துருப்பீங்க. இந்த இதுக்கு பேர் தான் லூப்னு சொல்றாங்க. So amplifier, tank circuit, feedback circuit. இது அப்படியே சொல்றது தான் loop சொல்றாங்க. So that addition A beta equal to 1. அப்படி இருந்துச்சு அப்படின்னா it can produce the sustained oscillation. So different oscillators are there by using the different tank circuits. That oscillators are Hartley oscillator, Colpit oscillator, and phase shift oscillator, and crystal oscillator. So these are all the oscillators. So what is the application of the oscillator? Application. So first application, to generate the periodic sinusoidal and non-sinusoidal waves. I already told you that sinusoidal, what is meant by sinusoidal and non-sinusoidal wave. So using that we can produce the sinusoidal and non-sinusoidal wave. To generate RF carriers. RF carriers means radio frequency carriers. The next one, to generate audio tones. So using that audio tones, we know that communications and we studied that. To generate clock signals in digital circuits and as sweep circuits in TV sets and CRO. CRO, TV இது எல்லாத்தையும் யூஸ் பண்ணிக்கிறோம். CRO means cathode ray oscilloscope. நீங்க அதெல்லாம் பார்த்துட்டீங்க. அந்த ஹாஸ்பிட்டல்ல பாத்தீங்கன்னா ஒரு இதுல அப்படியே ஹார்ட் வேவ் மாதிரி அப்படி போயிட்டு இருக்கு பாத்துருக்கீங்களா அந்த மானிட்டர்ல, அதுதான் வந்து cathode ray oscilloscope. Okay, electronics. Digital electronics. Digital means you know the two type of waves are there. One is the digital wave, another one is the analog wave. Analog wave means it is a sine wave. Sine wave na paathum illaya, other digital analog wave. So that amplitude of that wave is gradually increases and decreases. That's called analog wave. So see that this wave is called analog wave. So that amplitude of that wave is increases and decreases. It is slow like this. It is called amplitude analog wave. Digital wave means it is 0 and 1 is there. It is like this. It's a square wave, you know. So this is the digital wave. It has only two values. One is 0 or 1. So 0 or 1 you can say that, or it is low, high. Low means this one, high means the maximum. Low, high, or 0 or 1. Okay, or on, off. It's off and on. Or you can say that any word. So the three words can explain that. So these are the two waves, analog and digital waves. So positive, negative logic means plus 5 is here. See, it's a plus 5 means it is 1 and this is 0. For negative means that again 0, 5 one is 0 and this one is positive. For the negative, this is for positive. So 0 and 1, only they are the two values, 0 or 1, high or low, on or off, like that. So logic gates. Here, logic gates are using in electronic circuits and basic building block of all the digital systems. Here we are using the three basic gates, that is AND, OR and NOT. So using that logic gates, we can construct that exclusive OR, NAND gate and NOR gate. Okay. So these are all the logic gates: OR gate, AND gate, OR gate and NOT gate. See, AND gate. So A and B are called inputs. The gate has the one output and more than one input is there. Here A and B are the two inputs and Y is the output. A, B are the variables. So Y equal to A plus B. Here the plus is the operator. The plus is called operator. So using that logical operator, we can add that value, multiply that value, or we can do any calculation by using that operator. That Y is a logical constant. Logical statement equal to Y equal to A plus B. Okay, right. So in that three gates, first we are going to see that AND gate. See, AND gate is here. That AND gate is, it can multiply the two values. Y equal to A dot B. It's a booklet tappa kuduthirukanga. It is not A plus B, it is A dot B. Okay, so A and B is here. So Y equal to A dot B. It is not plus, it is dot. So we are multiplying the two values A and B. So multiply the two value means 0 into 0 you will get 0. 0 into 1, 0. 1 into 0, 0. So 1 into 1, 1. So AND gate, when you are having the two inputs are high, you will get that output. Otherwise, you won't get any output. In OR gate, see that it is operation is Y equal to that logical operation Y equal to A plus B. We have to add the two values. Okay. So these are all the two inputs. So 0 plus 0, 0. 0 plus 1, 1. 1 plus 0 is 1. 1 plus 1 is not equal to 2. You have to write it is 1. So it has only two values, high or low. So when now adding the two values, 1 plus 1 is equal to what? That means it has high value. So without any input of the two inputs, other inputs are having that value of high value. Okay. So this gate is called OR gate. And then last, that is NOT gate. NOT gate, it will give the receiver complement of the input. Complement of the input. A is the input, A equal to A bar. This A bar means it will give the reciprocal output. That means suppose you are giving that input 0, it will give 1. So 0 means 1. 1, if you are giving that input 1, you will get 0. Okay. So like that it will give the output. See that in animation. So these are the three gates and the or not. The electrical circuit is the building block of all the electronic circuit. Whatever it is, computer or cell phone or whatever it is, it's made up of only these things. So actually adding we like this 4 plus 7, 11, 2 plus 3, 5 like that. They are adding the numbers. So like that operations are made by the logic gates. So three gates are there, R and are not. So using the three gates, we can build any electronic cycle. So it only has 0 and 1, or we can say that 0 or 5 volt, high or low, or true or false, anything. In maths, you are going to do in the true or false method. So physics, you can say that in 0 or 1, high or low. So the two inputs are on and off. Like that, you are going to do the practical also. Practical lab, you are having like this. Okay, that's called the truth table. First one, we are going to see the NOT gate. So one input and one output. This off means the light bulb is glowing. So it is a reciprocal. See, one means 0. See, and the switch is on or off. This shows that. Next thing is OR gate. OR gate can add the two values. So add the two values means any not that is our solve get the asset value. Any one input is that you can get the output. And AND gate is y equal to a dot b. So multiply that to value. Booklet please change that. So except 1 and 1, remaining all the input here. So these are the three gates building block of all the gates. So using that case, we can construct like this large number of gates. Any operations can do that. So these are all the other three gates: NAND, NOR, and exclusive OR. So NAND plus NOT NAND, OR plus NOT it's NOR, and exclusive OR gate is there. So these are the other three important gates. That three gates can be constructed by using the other three gates. So first thing, exclusive OR. In exclusive OR, that y equal to a plus b, that is inverted, reciprocal to that a plus b. You have to add the two value and get reciprocal. That is the exclusive OR. So see that. So using the NAND gate, only NAND gate, we can construct all the three gates, NAND, OR, and NAND. Okay, so this is the logic gates. The NAND, NOR, and the exclusive OR gate is here. So NAND gate. So any one input that except that 1 and 1, remaining all the values have the value. Y equal to a dot b. You have to multiply that value and you get a reciprocal. See, 0 to 0, 0, 0 reciprocal is 1. 1 into 0, 0, 0 reciprocal is 1. Like that you will get all the values. It's called NAND gate. AND gate plus NOT gate. So it's called NAND gate. The next thing is NOR gate. OR gate plus NOT gate. OR gate value, you know that y equal to a plus b. NOT gate is reciprocal. So you have to add the two value and get the reciprocal like that. So 0 plus 0, 0. 0 reciprocal is 1. So this is the NOR gate to take. And exclusive OR. So here you see that is the exclusive y equal to a dot b bar plus a bar dot b bar. So b bar means it is reciprocal to the b value. A bar means reciprocal to a. So like that you will get y equal to a plus b. So here you can see that exclusive OR. For the value of 1 into 1, that is 2 high value, you will get 0. Okay. So these are all the other three and the operation difference is the 9.52. So now that complement law. Complement means you know that a equal to 0. That is reciprocal. The reciprocal of 0 is 1. The reciprocal of 1 is 0. So the complement law can be realized as a double bar equal to a. See the another one law, a bar means it is reciprocal. A double bar means you will get the same value. So bar cancel each other. Then R law means we have to add the two value. So here y equal to a plus b. Adding the two value, you will get this value. So for 1 plus 1, it is not 2. It is again, you will get 1. So R laws can be realized. See that this is for letter. First law, a plus 0 equal to a. Second law, a plus 1 equal to 1. Third law, a plus a equal to not 2a. It is a. And fourth law, a plus a bar. Bar means it is reciprocal to the a. So when you add that a plus a bar, you will get 1. Then AND law. AND law means you have to multiply that. See 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, 1 into 1, 1. So it's called AND law. Then AND laws can be realized in the form of a. First law, a dot 0, 0, a dot 1, a. A to a, not a square, again it's a. Fourth law, a to a bar becomes 0, it is not equal to 1. So see the difference. Commutative law, you know that a plus b equal to b plus a dot b equal to b dot a. So these are the Boolean algebra obeys these laws. Associative laws, a plus b plus c equal to a plus b plus c. So we know the associative law. Next one, distributive law. So this also satisfies the distributive law. So the above laws are used to simplify the complicated expression and simplify the logical circuits. So more number of logic gates are connected, and what is the output is coming. Using that last Boolean algebra, we can find out what is the output that will come from that cycle. The last thing is important thing is De Morgan's theorem. De Morgan's has the two theorem. The repeatedly asking question. De Morgan's has the two theorem. One is the De Morgan first theorem and the De Morgan second theorem. De Morgan first theorem. De Morgan first theorem is De Morgan first theorem. The sum of complement is equal to the sum of complement is equal to the product of its complement. Product of means a bar dot b bar. So sum of its complement means a plus b whole bar. That is sum of complements is equal to the product of its complement. It's the product of complement. See that a plus b whole bar equal to a bar dot b bar. So it has the proof. See that a plus b whole bar, a bar b bar, a dot b bar is here. So in this, you know that what you have to do. You are adding two values. Again you can get the reciprocal value. So here that a bar is the reciprocal of a, b bar is the reciprocal of b. So multiplying these two values you will get. See that a plus b bar is equal to a bar dot b bar. So these two values are equal. It's a De Morgan's first law. The sum of complements is equal to that complements of the product of two equals. So first law is complement of sum of two logical inputs is equal to product of its complements. So this is the first law. Just see that next one is the De Morgan's second law. De Morgan's second law is also same. So here the update the reciprocal and three put complement of product of two inputs is equal to sum of its complement. அங்க வந்து sum is equal to product. இங்க என்ன வருது அப்படின்னா product is equal to sum. So complement of product of two input is equal to the sum of its complement. So here again the proof is here. So the two law with proof, it's a 5 mark question. So see that A dot B whole bar and A bar plus B bar. See that A dot B whole bar and A bar plus B bar, that are the same value. So in this table, the two values are equal. A dot B whole bar equal to A bar plus B bar. So this is the De Morgan's second theorem. So De Morgan's first theorem is proved, and also NAND gate is equal to the bubbled OR gate. So using these two gates, we can prove that this is table form. Okay, so this is the De Morgan's first theorem and second theorem. So very important. Repeated up carefully. Only in the equation and the statement after the proof கேட்டாங்கன்னா proof over. So that one important ஆனது. Then finally the last topic, integrated chip. Integrated chip we are going to பார்த்துட்டோம். After inverted the transistor, that integrated chips are discovered the year of 1958. So it has the different size of the integrated chip, very large scale, small scale, medium scale, like that. It has different length is there. That integrated chips are made by the transistor, resistor, capacitor, and other small components. So it's a very small in size. We can make that the energy cannot be radiated by the transistor. So we can use it in a very small size, and large number of components are used in the integrated circuit. So using that, the very large scale integration is possible for the manufacturing of IC circuit by miniaturing the components. So using that, we can produce the low cost and performance and the size and speed and capacity of the business are very high. That is enormously increasing the technology. The computer, mobile phone, digital phones, everything we are using the integrated circuit. Okay, so that is the basic thing for the integrated circuit. So this extremely small ICs can perform the calculations for data using digital and analog technology. And digital ICs, logic gates work only in the values of ones and zeros. So 1 and 0, இது மட்டும் தான் யூஸ் பண்ணி லாஜிக் கேட்ஸ் ஒர்க் பண்றோம். ஸோ இதை யூஸ் பண்ணி நம்ம பண்றதுனால இந்த டிஜிட்டல் ஐசிஸ் ஆர் கால்டு 0. It has the value of only 0 or 1, only two values. So it has two type of ICs are there. One is the digital ICs and the analog ICs. The digital ICs are used in the applications of computers, network equipment, and most consumer electronics. But analog and or linear ICs, another one type is analog or linear IC. That is used in the linear IC can take the audio and radio frequency amplification. So it is used in the communication purpose, that analog IC. So we call the IC. That's